According to de Broglie, matter behaves like a particle and a wave. According to him, every moving particle will have its own wavelength. Every moving particle has its own wavelength and defined as lambda is h by v. That is momentum. So h by lambda here represents momentum. The P stands for momentum. Here, error in P, he is asking log P is equal to log A cube B square by CD, which is 3 log A plus 2 log B minus log C minus log T. So while considering error, differentiating with respect to P, plus 2 delta B by B. Here, while calculating error, maximum error we calculate. Here, even though minus, we write here plus. So percentage error is 3 delta A by A into 100, 2 delta B by B into 100, plus delta C by C into 100, plus delta D by D into 100. So percentage error in measuring A is 1%, percentage in B 2, percentage in C 3, percentage in D 4, 7, 11 plus 3, 14%. Here, average velocity is net displacement by time. It's moving in a straight line with a constant acceleration, then displacement is ut plus half at square. So average velocity will be displacement by time half u. The slope of a velocity time graph. So here velocity time graph tan theta is v by t. For a retarded motion means acceleration is negative, v by t negative, tan theta negative. So slope will be obviously negative means. So that line makes an angle, obtuse angle. Here, hollow cylinder has a charge q coulomb within it. Phi is the electrical flux through the curved surface B. So here, total flux is q by epsilon naught. One is through this surface A, other is through surface B, other is through surface C, which is q by epsilon. So here through this surface or through this surface, flux will be equal. So 2 times pi A plus through surface B, he given that phi is the flux. Phi A will be 2 by epsilon naught minus phi divided by half. So what is the angle between maximum value of potential gradient and the equipotential surface? Suppose let us consider equipotential surface. For equipotential means wherever you choose 2 points on the surface, potential will be same. then such surface is equipotential surface. So here in equipotential surface, so potential at A is this, potential at B is this. So when it is moving from A to B, potential is same. V here is in fact minus E dot dx. So here it is potential difference from A to B, let us say. So this is 0, which implies E dot dx is 0. So E dx cos theta is 0. So neither E nor dx is 0, cos theta is 0. That means theta is 90. So for maximum value of potential gradient, angle between potential gradient and equipotential surface is 90. Component of A bar along B bar is A bar dot B by B bar, which is same as projection of A along B. 2I plus 3J dot I plus J by mod of 5 plus, which is 2 plus 3 by 5 by root. What determines the nature of path? So here, so when a particle is moving with some velocity, its path is determined by the force, whether it is moving in a straight line or it is moving in a circular path, some trajectory. So path determined by a force, that is acceleration, and as well as velocity. Two solid spheres, each of mass m and radius r, are kept in contact moment of inertia of the system about the tangent passing through the point of contact. So we know through the center of mass, moment of inertia of a solid sphere about an axis which passes through the center of mass is this. By parallel axis theorem, moment of inertia of the one sphere about the tangent will be mr square plus mr square, that is 7 by 5 mr square. So now moment of inertia of two spheres about same axis will be 14 by 5 mr square. A body is revolving in a vertical circle. Speed of the body at the highest point is 2 root rg. At this point, we don't know velocity, let us say u. At the lowest point, what is the speed means? Take this as a reference line of mu square is equal to, here at this point only kinetic, no potential. At this highest point, it is at a distance 2r and plus half mv square, v square is 2r. So here it is 3 mgr, half mu square U square here is 6gr. So any velocity of your body at the lowest point is root 6 orange. So here in an orbital motion, this angular velocity, angular momentum, torque. So the direction of they are all axial vectors. Their direction will be perpendicular to plane. A car of mass negotiates a banked curve on a frictionless road. For banking angle, we have a formula. The speed of the car will be R here is 90, G is 10 and 45. V here is 30 meter per second. Moment of inertia of a circular loop of radius R about an axis of rotation parallel to the horizontal diameter and at a distance R by 2 from the diameter. This distance is. So moment of inertia of a circular loop is mr square about an axis, mr square by 2 about diameter, then about AB by parallel axis theorem about diameter plus m r by 2 whole square. It is mr square by 2 plus mr square by 4, which is 3 mr square by 4. Here for a satellite moving in an orbit, so once it moves in an orbit, of radius r, potential energy is minus gmm by r. Kinetic energy is, so here v is orbital velocity. Orbital velocity is root gm by r. Right. So v square is gm by r. Here it is gmm by. So here kinetic energy to potential energy magnitude wise half it is. So limits of Poisson ratio. Poisson ratio can be positive or negative, and it is defined as so Poisson ratio is lateral strain by longitudinal strain. So here there are two different possibilities. Lateral, once you take so any wire, once you stretch it, its length increases as well as cross-sectional area decreases. Once cross-sectional area decreases, lateral strain means it is a delta R by R decreases. delta L by L. So here, so this is Poisson ratio. So here maximum value of Poisson ratio is half, and some materials, once you stretch it, so instead of increasing the decrease in the cross sectional area, there is an increase in the cross sectional area. So for those materials, these two becomes positive and minus. So Poisson ratio can be negative. So it is in fact lies between minus 0.5 to 0.5. It's the fourth option. So black body ready is at 720 degrees. It emits energy. So amount of energy radiated per second by Stefan's Boltzmann law. Sigma is Stefan's constant. So here it is Q is proportional to T power 4. T is your absolute value 727 plus 273 degrees, which is 1000 Kelvin, 10 cube. So amount of energy radiated is 10 cube power 4, that is 1000 power 4. A metal block has a length 50 centimeter, breadth. When a current is a metal block, length is 50, breadth is 30, and thickness is breadth 20. Right? When current passes through parallel to the length like this, what is its resistance? Rho L by A. Your cross-sectional area will be this when current passes. Rho L here is 50. Area is dimensions 2030. So rho by 12. When it passes parallel to the breadth, then breadth is 30. Area becomes remaining dimensions 3 rho by 100. Now he is asking resistance R2 by R, 3R by 100 by rho by 12. 36 by 100. So R2 will be 9R by 25.